Hello! In this video we're going to verify the trig equation given is an identity. This is a homework problem. How are we going to do that? How do we verify identities? Well, let's talk about our goal. The goal here is to start with one side. This is how you always verify identities. You start with one side. You manipulate only that side so it ends up identical to the other side. And you know that you have an identity. There's a bunch of hints. The first hint was learn the fundamental identities, and that was in the last section. Make sure that you know them. Substitute one of these identities whenever possible. Always try starting with the more complicated side. So, in this equation, which one? Let's talk about that. Which one is more complicated? Well, to me, there's not one side that is more complicated to the other. So I'm going to randomly pick one side. But in general, I would start with the more complicated side. Okay, next. Sometimes it is helpful to express all the trig functions in terms of sine and cosine. So for instance, we have cosine and a secant here. Those are two trig functions. Secant, well, to me that's blaring that should be in terms of sine and cosine. That would be that hint. Change that to sine or cosine. And we know by the fundamental identities, I listed him here, that we know that secant is 1 over cosine of theta. We have that identity. So let's go ahead, and do that. Okay, so instead of secant, I'm going to write 1 over cosine of theta. And then everything else should stay the same. Okay. Next, always try to simplify and factor if possible. Well, here we can simplify. We can multiply top and bottom by cosine of theta. Get rid of the double fraction. We don't like the double fraction. So what would that be? The top would be cosine squared of theta. The bottom, well, when I use the distributive property, if I multiply the first term with the cosine, I would get 1, and the second term would be minus cosine of theta. Now, by the way, we're keeping in mind our goal to end up at the other side, and I'm nowhere near it. So I'm not sure what to do next, maybe. We might say that. Well, let's move on to the next hint. If one side contains more than one fraction, like two fractions, try rewriting it to get one fraction by getting an LCD. Well, ours doesn't have two fractions, so I'm going to skip that for this problem. But the next part, if an expression contains 1 plus sine or 1 plus or minus sine or 1 plus or minus cosine, multiply the numerator and denominator by its conjugate. Well, we have that because we have a 1 minus cosine. So I'm going to go ahead and multiply top and bottom by the conjugate. So let's go ahead and do that. So I'm just rewriting the problem, and then I'm going to multiply top and bottom by 1 plus cosine, because the conjugate of the denominator is, right? If you remember what conjugate means, it means the same two terms, but instead of a minus, it's a plus. And if it was a plus, you multiply by a minus. So what do you get there? Now, I'm not going to multiply the numerator here because I always think about my goal. Here's the first part where it comes tricky with the trig identities. If I multiply this, notice my goal. My goal is cosine of theta plus 1, and I have that now. It's looking good. So I don't want to get rid of that. So I'm going to leave that there. So I'm going to leave cosine squared of theta, but I'm going to leave that 1 plus cosine of theta there. And then the denominator, I'm going to use FOIL. So if I use FOIL here, what would that be? I would multiply 1 times both of these. So what would that be? That would be 1 plus cosine of theta. And then I would take this term and multiply by both of those. I would get a minus cosine of theta minus cosine squared of theta. Now notice how those middle terms cancel. So what we end up with is, I'll just rewrite the numerator the same, but the bottom is now going to be 1 minus cosine squared theta. Getting closer. Okay, 1 minus cosine squared theta you should recognize as sine squared theta. To show that, let me scroll down. Let's look at sine squared plus cosine squared equals 1. I wrote it down right here. We should recognize that you can get 1 minus cosine squared out of that by subtracting cosine squared of theta from both sides. So we get that sine squared theta equals 1 minus cosine squared theta. That is a good formula as well to memorize. You could do the same thing for both sides. If we erase this and subtract both sides by sine squared theta, we would get cosine squared of theta equals 1 minus sine squared theta as well. So these are two good formulas to memorize as alternates to sine squared plus cosine squared is 1. And if you notice, I do have 1 minus cosine squared. So I can substitute that in for sine squared. So again, just rewriting the top, the denominator we know would be sine squared theta. And let's scroll up again to our original. Believe it or not, we are so close. Because if you notice, this cosine of a sine is cotangent, cotangent squared. And this is 1 over tangent, which is also cotangent squared. So we're getting close. So the next thing I'm going to do is quite tricky. Let me rewrite this equation. My goal is to get tangent squared theta and get rid of this cosine. So to me, this cosine has got to go. So what I'm going to do is, to get rid of it, I'm going to multiply 1 over cosine squared, the top and bottom, the same trick I did above. That would cancel theta. That would cancel with that, giving me a 1 plus cosine theta. And on the bottom, it would be sine squared theta over cosine squared theta. So you can see here we are so close because we know that sine over cosine is tangent. By the way, that is the hint, the last hint. It says, as you select your substitution, always keep in mind the side you're not changing because that represents your goal. So I'm always looking at my goal and I can see that I'm almost there. Sine over cosine is tangent squared of theta, and then I would have it. So all I got to do is write that last line and I am done. So let's go ahead and do that. Let's scroll down a little bit. I'm going to keep the top the same, and I'm going to write the bottom as tangent squared theta. And you can see we are done. Oh yes, well we can change 1 plus cosine to cosine of theta plus 1 if you want to get it to exactly alike. And we have just verified the identity. One last thing to go over. If you ever are stuck and just cannot think of a trick to get to the right-hand side, there is a note here that might be helpful to you. Let's talk about that. Working with both sides is sometimes a good alternative when identities are difficult. So what I would do, you would try one side, see if it works. If that doesn't work, you try the other side. Somewhere along the way, it may happen that the same expression occurs on both sides. If this one, you pick one side and reverse each step so it leads back to the other side. So sometimes that is a good trick to do. Caution. I need to make sure we understand this caution. The procedure for verifying identities is not the same as solving equations. Techniques used such as adding or subtracting the same quantity to both sides should not be used when working with identities. So you notice here, I never went to the beginning and multiplied both sides by the same quantity. Right? We never use the right-hand side or cross-multiply. Yes, this side will equal that side, but that is not how you verify identity. You verify identity by starting with the left, working, not messing with the right, and getting the right at the end, or vice versa, starting with the right, not messing with the left. So that is how you verify identity. Hope that helps.